At this point, we've leveraged many of the structural tools in the Explore stage. We can now switch over to the Refine stage, where we'll be able to create more accurate solutions with the Ansys Mechanical Solver. We can do so by clicking on the right arrow next to Explore under the SID. Entering the Refine stage will shift you from the GPU solver to the mechanical CPU solver. This means you will now deal with a conventional mesh and have more simulation options. Note that you can transfer to Ansys Mechanical from this stage too. The difference in exporting from Refine is that you will be able to transfer the mesh created. Now, to access the additional simulation options, click on the drop-down arrow of the Simulation Options button. This is found in the Physics group of the Simulation tab. Here, you will be able to select additional structural options. In the Fidelity group, you will now be able to adjust the mesh by clicking on the global drop-down arrow. Note that you can still assign local meshes, and in the Refine stage, you can also assign a local mesh to surfaces and curves. We'll leave default settings for now. Let's also clear our local mesh created in the Explore stage to start from a clean slate. From here, we can either solve or preview the mesh first. Let's go ahead and preview it first. To do so, click on the Generate Mesh button in the results arc. The mesh will begin to generate. Note that generating meshes and solving in Refine may take longer, as we are now using the CPU solver and not the GPU solver. Therefore, let's fast forward. Now that we have generated the mesh, we can move forward or make any mesh adjustments from the global mesh settings, or we can also create a local refinement. You can also look at the cross sections of the mesh by clicking on the Cut Plane button in the results arc. For our case, we'll need to update the local mesh, as the mesh is not as clean as we would like it to be. Note that now that we are in the Refine stage and working with a conventional mesh, we'll need to ensure that we have a proper mesh to both be able to solve and have proper results. The mesh is being heavily driven by the curvatures throughout the assembly. Therefore, we'll want to change the mesh approach to proximity only. This will allow the meshing approach to be driven by the areas between opposing faces and/or edges instead. We'll do this by clicking on and deactivating Determine Size automatically, and then selecting Proximity. We can now generate the mesh again or begin the solution. Let's solve this time. Let's skip ahead to the complete solution. First, let's take a look at the mesh. You'll be able to see that the mesh looks much better now and was able to produce a solution. Now, if not on it, switch over to the von Mises stress in megapascals and open the corresponding monitor as well. We can see our results, including the stress at the refined regions. We can also see the new maximum stress value in the monitor. Note that in the refined stage, you can set joints and bolt monitors to track things such as joint total force and bolt axial stress. We'll wrap up the Refine stage discussion here, but note that you can continue to perform the same design exploration exercises we did in the Explore stage, and instead leverage the mechanical CPU solver. Further refinement can be performed by improving the mesh and refining areas of high stresses. Additionally, note that the physics setup can be performed in both the Explore stage and the Refine stage. So we could have started the session in the Refine stage and skipped the Explore solutions if wanted to.